The audio preamp in the lower right side of the Theremin block diagram allows us to modify the volume and the brightness of the musical instrument sound. It takes as an input the signal coming from the VCA and provides its output to the audio amplifier that we already built in the previous episode of the Theremin Project series. Today we will go through its schematic diagram. We will build it on the perf board hosting all the other blocks of the Theremin, and we will do a qualitative test to make sure it works as expected. Hi there! I am Carlo Carrano, and this is Electronics Engineering Made Easy. This simple preamp is made up of two stages. The first one, made of the transistor Q1, the resistors R1, R2, R3 and R4, and the capacitors C1 and C2, is a decoupling stage between the input from the VCA and the output toward the brightness control. Capacitors C1 and C2 are used to decouple the preamp stage from the DC, so that only the actual audio signal can pass through. Resistors R1 through R4 are used to polarize the transistor Q1 at the center of a linear region of its characteristics, so that the signal gets slightly amplified without being distorted. Trim-pot RV1 is used to provide the right level of signal to the preamp stage, to avoid the saturation of the signal and corresponding clipping if the input signal is too high. Resistor R5, along with capacitor C4, provides a low-pass filter, while the capacitor C3 and the resistor R6 provide a high-pass filter. Potentiometer RV2 picks the signal more from the low-pass filter or from the high-pass filter, depending on where its cursor is positioned. Since the signal handled in here is always sinusoidal, this control does not really change the harmonic contents of the signal, like it would be done by an hi-fi preamp. Instead, it provides different responses to vast range of frequencies the Theremin can provide. When the cursor is mostly on the side of terminal 1, the Theremin will provide a sound that is more powerful at the low frequencies and become less and less loud when the frequency increases. Vice versa, when the cursor is moved toward the terminal 3, the most effective sound happens at the highest frequencies rather than the lowest. This control, therefore, rather than providing a tone control, it provides a change in brightness of the sound. The signal at the cursor of the potentiometer RV2 is then passed to the next stage of the preamp, where it gets further amplified. This stage is similar to the first one. Its main purpose is to bring back the overall amplitude of the signal after it has been attenuated by the brightness filter, so to provide a signal high enough to correctly pilot the power amplifier. Potentiometer RV3 regulates the amplitude of the output signal, so it basically provides a volume control to the audio. Here are some pictures showing the assembly of the preamp on the perf board, where already other elements of the Theremin have been assembled. Note that the preamp is assembled very close to the existing power amplifier, and in particular, it is located on its immediate right and top. Easy to see is the trim-pot RV1, which is located at the center of the lower edge of the board. Right above is located the transistor of the first stage of the preamp, whereas the second stage transistor is located on the upper left of the area, close to its polarization resistors and a couple of electrolytic capacitors. Also visible are the two 3-prong connectors used to attach the brightness and volume potentiometers. And finally, here are a few overall views of the final assembly positioned within the Theremin box, where you can see how the two potentiometers are connected. I will now do a qualitative test of the preamp. To do that, I will need my function generator connected to the input of the preamp, in particular at the trim port RV1. The function generator is set to provide a sinusoidal wave. Let's start by checking the volume control to make sure that we can increase and decrease the volume of the sound emitted by the chain of the preamp and the power amp. I will just turn it on the system. And now you can see that I can control the volume up and down. To check the brightness control, I set the brightness potentiometer to a certain position and hear how the audio signal sounds at various frequencies. Then I change the potentiometer to a different position and hear if there is any change in the sound response at the various frequencies. We do want to hear changes happening. If so, it means that the brightness filter is doing its job. So far, we have gone through the design and assembly of the following elements of the theremin: the pitch reference oscillator, the power supply, the audio power amplifier, and the audio preamp. We have seen how each of these elements of the instrument work, and we did some kind of test on them to make sure everything was as expected. In the next episodes of the series, we will soon go through the remaining elements of the theremin, and we will finally see it working. If you liked what you saw so far, please take a moment to like this video, and, if you have not done it yet, click on the subscribe button and on the bell, so you can be informed immediately when a new video becomes available. See you next time, and happy experiments!